In this demo, we're going to show how to use MSC Sinda and Patran along with SindaRAD to do some advanced thermal problems involving radiation. We're going to go start to finish, and I'm first picking the MSC Sinda preference, and I'm going to load in a piece of CAD geometry. So I'm importing a step file, and I want to make sure that I'm in SI units. So I am in meters. Apply, and it will bring in the model. Now this is a model of an electronic box. It's about 10 inches long, and here it is right here. Has some small holes and a lot of features, but we're not going to defeature it. We're just going to use it just as it is. So I'm going to jump over to loads, and I'm going to put some loads on here. I'm going to put temperature at the mounting feet, mounting to be 25 degrees C. And for an application region, I'm going to pick these surfaces right here. That surface, this surface, this surface, and this surface. And we'll fix those to be 25 degrees. Then we're going to add 100 watts of total power. And I'm picking total heat, not heat flux, on elements on this back wall. So I'm going to just call this heat. We're going to put in 100 watts of total heat, and we'll pick this wall right here, surface of the solid, and hit apply. And the last thing we're going to do is we're going to add radiation. We call this enclosure radiation, and it's on elements, element uniform. And enclosure radiation means we're going to use a view factor program to calculate the view factors. So all we specify is an emissivity and an enclosure number. I'll just pick one. And then for selecting the faces, I'm going to select every face on this solid and hit apply. So now you can see the arrows showing we have radiation. Now we're going to go and pick a material, and I'm going to use our material library, which is an Excel file that has a bunch of materials in it, and I'm going to pick aluminum 6061 T6 and hit apply and then close. So now we have aluminum, and I was able to set the units, and it brought it in SI units. I could have changed them to millimeters or inches, any units I wanted, and it would have brought them in. Next thing I'm going to do is create a property, and we want a 3D property for a solid, and I'll just call this property solids. And we're going to pick aluminum, and we're going to pick this solid part here and apply. So now we've created a solid property. Now we'll just mesh it, and we'll create a mesh on this solid here. I'm going to turn off my loads, and I'm using TET4, and I'll hit apply, and I'm automatically calculating the mesh size. You can use TET10, but it doesn't buy you any resolution the way Sinda works, so we recommend using TET4. TET10s will just slow you down, and we don't really compute that extra node temperature. Okay, so now our model's completed. So we go to the analysis menu, and I'm going to pick, instead of sensor, I'm going to pick SSS or SSQRM. It's a good method for radiation problems like this. And I have to pick a radiation solver now under here. I have to pick radiation solver, say I want to use one, and pick one of these solvers. We're going to use SindaRAD. And I'm going to run it interactively so we can see the results. And one other thing I'm going to set here is the space temperature, and I'm going to set this to be 25 degrees C. This is like the enclosure temperature around this box. So whatever view factor this element doesn't see with other elements, it will see with the enclosure. And we'll just make this like sitting in a room at 25 degrees C. And then we go and run. And now it's going to first build a SindaRAD model, and then it will launch SindaRAD. And I said to launch SindaRAD in an interactive mode. So instead of just running in the background and you seeing a little reminder showing you how it's progressing, it's actually going to just drop into SindaRAD and then stop. So now it's just launch SindaRAD. And in SindaRAD, I have my model here, and I'm going to just calculate the view factors by hitting that button. Now this takes on this computer that only has one core. SindaRAD is multi-core processor compatible, so if you have 4 cores, it runs about 3.6 times faster, 2 cores 1.8 times faster, but this is an older machine, and it takes about 2.5 minutes. So I'll pause while it's doing this. So once SindaRAD's done, we can see we have 11,800,000 view factors, and I can take the left mouse button and double click on any element here, and I can see it color code what its view factor is. And that's useful in some cases, and that's why I ran it interactively, so we could see how to view that. Now I just exit it and I hit save, and it will now build the Sinda model and start processing Sinda. Takes about 20 seconds to build the Sinda model and about another maybe 30 seconds to run the model. Now it's pre-processing. 8,500 nodes, about 25,000 conductors. Now even though there are 11 million view factors in there, because I'm using the flux method, it doesn't actually put a radiation conductor from every node to every node, but it just puts the effect of that radiation conductor by pulling out a Q from one node and putting it into the other one. So this greatly simplifies the Sinda model and makes it run faster. So now it's done, and I'm going to access my results. And it says results are imported into Patran. And here are our results. And now you can see it goes from 25 degrees to about 68 degrees. The hot point here where the flux was added, and the mounting feet pinned at 25. So if we did want to change some powers or rerun this, we could come into SindaRAD or into the setup menu, and this time in SindaRAD we could say use existing results, and we'll take the interactive off. Now it will use the existing results. We could change the power or these boundary temperatures or conductivity of aluminum and rerun the problem.